A moonbase sounds like a city with rockets. The first one will resemble a remote industrial outpost. It must keep humans alive in a hostile vacuum. No air, useful weather, or nearby emergency department. Every small fault can quickly become a large one. The moon averages 384,000 kilometers from Earth. Every meal, filter, tool, and spare crosses that gap. Even a cheap bolt becomes expensive after launch. Lunar logistics will not include same-day delivery. Robots and cargo must prepare everything before crews arrive. Most serious concepts target the lunar South Pole. Some ridges receive long sunlight beside permanently shadowed craters. Those dark regions appear to contain water ice. That offers nearby power and potentially useful resources. But low sunlight creates long shadows and difficult terrain. A shadow may conceal a crater or steep slope. Sites balance sunlight, ice, safety, terrain, and communications. There is no perfect location, only respectable compromises. Elsewhere, lunar daylight lasts nearly 15 Earth days. Then darkness lasts nearly as long. Solar power works brilliantly until sunlight disappears. 2-week batteries become heavy, large, and financially educational. Reliable bases may combine solar, storage, and nuclear power. Long cables may cross rough ground between facilities. Sunlit surfaces roast, while nearby shadows remain freezing. Exposed areas can approach plus 130 or minus 130 Celsius. Permanent shadows can approach minus 250 Celsius. Habitats need insulation, radiators, heaters, and active cooling. Thermal control becomes a full-time engineering department. The moon lacks Earth's atmospheric and magnetic protection. Cosmic rays and solar particles reach the surface. A solar storm could force everyone into shelter. Thick regolith can shield habitats from radiation. Water tanks and supplies can surround a storm shelter. Micrometeoroids arrive without atmosphere to stop them. Walls must resist vacuum, impacts, radiation, and temperature stress. No building inspector is needed. Physics works over time. Then comes lunar dust, the least glamorous major threat. Without erosion, its grains remain sharp and abrasive. Electrical charging makes it cling stubbornly to equipment. It scratches visors, wears joints, and damages seals. Dusty radiators also become much worse at cooling. Bring it indoors, and the crew may inhale it. Suit ports could keep contaminated suits mostly outside. Electric dust shields may repel particles from surfaces. Brushing the moon clean is not a scalable plan. Inside, life support must create a miniature artificial Earth. Air circulates, carbon dioxide leaves, and water gets recycled. Closed loops save supplies, but create critical machinery. Essential systems need backups, spares, and repair access. The first lunar plumber may charge impressive rates. Humidity, wastewater, and urine become valuable resources. Plants may provide food, variety, and biological research, but greenhouses require power, water, space, and maintenance. They are not automatic salad subscriptions. Local water could reduce supplies launched from Earth, but the ice is probably not a convenient underground lake. It requires digging, heating, capture, purification, and storage. Drinking water effectively begins as a mining operation. Electrolysis splits water into oxygen and hydrogen. This supports breathing or fuel, but consumes serious power. Oxygen may also be extracted from lunar minerals. The material is abundant. The easy factory is not. Construction probably starts with autonomous excavation and grading. Robots could build roads, berms, foundations, and trenches. Landing rockets accelerate dust and rocks across the surface. That ejecta could damage nearby equipment and habitats. Permanent bases need landing pads and generous separation. Regolith might be melted into roads and pads. Printing helps, but does not repeal maintenance. First, Earth must deliver an entire industrial toolkit. Lunar gravity is roughly 1/6 of Earth's. Movement becomes easier, but often much stranger. We lack long-term data on continuous lunar gravity. Exercise likely remains essential for bones and muscles. Bulky suits and low traction complicate ordinary work. Crews may spend months inside compact technical spaces. Crew selection matters when the coffee machine fails. Earth communication is nearby, but never instantaneous. Radio signals take roughly 1.3 seconds each way. Calls gain pauses, interruptions, and deliberate customer service. Terrain can block signals, requiring towers or satellites. Crews must operate through weak or unavailable connections. That demands autonomy, procedures, and organized spare parts. At a moonbase, everyone joins the maintenance department, so why build one? It could unlock geology, polar ice, astronomy, and experiments. It could test systems for much more distant missions. It would reveal how off-world settlements actually grow. The real moonbase will be dusty, expensive, and fascinating. Thanks for watching. Like the video, comment, and subscribe.